So the char data type is a single byte. Or if you need to use Unicode in order to let them type in Russian or whatever, then you'd have to compile it in such a way that they would be a double byte character. But it's still the same idea. So every character can hold one and only one letter. And every character has to be defined in single apostrophes rather than double quotes. A character literal is something that's got single quotes around it. A character string is a whole string of them. Normally we define them as a string, right? Normally we say string S equals hello. But fundamentally behind it all, it's what's known as an array. Or what in Python you probably called a list. I know you called it a list because that's what it's called. In which case it would be declared something like this. Like that. That would declare it as an array. Now, strings are cool, much cooler. There was a reason that that class was invented so that you wouldn't have to deal with them as an array. But if you ever look at old C code rather than C++, you'll see these used all throughout it. And so we will brush up on what this means. But what it means is that it's a list of characters, right? Just like in Python, whenever we created a list, we use those square braces. It's a list of characters. It's got all of the characters, and then it's got a final 0 at the end of it. Why the final 0? Just so it knows when to stop. If you were going to print this out, how would it know where to stop if there wasn't a 0, right? Because there'd be something else in memory right after it, and then something else in memory right after it. When you try to print it out, it'd just keep going forever. Well, not forever, but until it found a 0. That's where it would stop. So the C++ string class, you do # include the string. You declare your variables like that. You always have to declare your variable before you can use it. You just sign them like that. You can add them together if you want. We could create a new variable called, full name, and it's equal to first name plus a quote, space, quote, plus a last name, right? Called concatenation when you append strings together like that. Oh, why not make a project? I believe we're on F. One Monday, Wednesday class is now 2 days behind since first week didn't have a Monday and this week didn't have a Wednesday. Lecture F. Oh, and a good point is if you try to email yourself a .cpp file, or you've made a .cpp file at school and you want to open it up at home and get it to compile, unfortunately what you have to do is make a new project and then create a new file and paste all the contents in there or something equivalent to that. You can't just open up a CPP file. If I went to open file here and I found a CPP file, I would not be able to run it, and I wish I could. I wish I did not have to create a brand new project in order to do it. But I do. So if you try to download something that you did at school and use it at home or vice versa, it's not going to compile until you make a new project. Alrighty, so let's just do what we did right there, right? String name, or first F name, equals Bob, in quotes. String L name, that's an L, not a 1, equals Roberts, end quote. String full name equals F name plus a quote, space, quote, plus L name. And then we could print out, hello there, space, end quote, less than, full name, less than, ENDL. And it's going to say, hello there, Bob Roberts. Now that alternate way of just creating a series of characters that I showed you looks like this. I'm going to call it SZ name, and then put that symbol there. That means it's a character array, equals, and I'm going to put some kind of data in here, right? John. Right. Now this is a character array. It's not a string. The string has a whole bunch of functionality that this doesn't. If I wanted to read in some data, this absolutely would not work, so I'm going to comment it out. But if I tried to do that, that would not work. Whereas I could read into any of these other variables I've created. But it's because, what, CIT? What's that supposed to be? CIN. This stream class cannot read into this thing because it wouldn't know in advance how many characters long it was. When this is declared like this, we only have 4 spaces of information, plus that invisible hidden 0, right, that the slide showed. It's called a null terminated string or 0 terminated string. And so that's where some people got the habit of typing in SZ, meaning string 0 terminated. And it didn't have to do that, right, but it had to have some name that was different than all of those. I could have just called it name, right, worked just as well. But can't do that. This only has room for 4 characters plus that trailing 0. So that array is only 5 spots long. What if you did CIN arrow arrow name and you typed in 6 characters? It's going to write past the end of the array, and all sorts of things are going to mess up. Whenever you start writing past the end of a variable, then you're corrupting other memory in your program. Probably to crash your program. Hopefully to crash your program. The best case when you overwrite memory is for your program to crash. The worst case is for some data to get corrupted and you don't know it, and so some calculations later on happen, right? So something bad is happening, you'd really rather for it to break your program right then and there so you know it and you can fix it. So we can't do that. If you wanted to get input, you'd have to use something called scanf in order to read input from the keyboard. And it's worth us talking about, but not right now. Floating point data types. Float, double, and long double. They hold so-called real numbers. Real numbers are just numbers that have decimal places. Stored in a format similar to scientific notation. So inside the computer, this is being stored as something like 0.1245 exponent, whatever it would take to get that to work, and for something like that. That's how it's stored in the computer, except in binary instead, right? So it'd be in base 2 rather than base 4. So some of the bytes are dedicated to that part. Some of the bytes are dedicated to that part, the exponent, stored inside it. All floating point numbers are signed. You can't make an unsigned floating point number. So single precision goes up to 3.4 with 38 zeros behind it, right? So 3 followed by 38 zeros, or a dot preceded by 37 zeros, right? So it's kind of precise, but look how much more precise this one is. You could do a 1 followed by 308 zeros. That's really a lot of zeros, right? Or you could have a decimal point followed by 307 zeros and a 1, right? Far more precise. Just always use double as a matter of course. And check this out, a long double, it's just the same thing. Why even have it? I don't know. Some future C standard may require that a long double is going to be 16 bytes rather than 8. right? So just like the ints, you have different sizes, different number of bytes dedicated to them. If you remember, we said that an int was 4 bytes and a long was 8. So you'd want to use a long to hold large data. However, it still was limited to certain size. I forget what. We could scroll back up and look. Come on. Well, however many zeros that is, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right. So 1 followed by 18 zeros is the max that a long can hold. Whereas a 1 followed by 380 zeros, or whatever that number is the max that a double can hold. If you need to hold astronomically long numbers, you'd probably want to use a double. And I've talked about the drawbacks of doubles and floats, is that you get rounding errors when you do math with them. And it's not like an error, it's not something, it's to be expected. It's just a matter of fact that you can't hold an infinite number of digits in your computer's memory, and so things get rounded off. Let's talk about that again. If we have two floating point numbers, remember that one where we had a number that was almost equal to 1, and then we had another number that was equal to 1, right? So say you had a number that was like that, and then your target number was 1. You wanted to check to see if that equaled 1. So you did this, if d is equal to 1. That's not going to work. So instead what you have to do is find out what the difference is between it and 1. So this is not going to cut the mustard, right? Because it does not equal 1, but it might be close enough for our purposes. Maybe that 0.01 was introduced by a rounding error. So I'm going to leave that there, but here's how you really would do it. You would take the difference between that and your target value, right? So double diff equals d minus 1. And then you would take the absolute value of that, right? If the absolute value of the difference is less than whatever threshold was acceptable, right? Let's say that that close to it is acceptable, then we could print out like close enough. Whereas this one, let's make it say the same, but it's not going to say the same. We would never see that because they're not. This is not equal to 1, but it's close enough, right? If that's our definition right there of what makes it close enough. So when you're doing comparisons of floating point numbers, you usually need to do it like that. It's a bit of a drag. You could simplify it all into one statement, right? We could say absolute value of d minus our target, right? Whatever our target is, like that. At least it's in one statement, but it's still considerably more complex. But hopefully the math isn't too bad. I hope you remember what absolute value means. Absolute value means you drop the negative sign if it is 1. Why? Because when you subtract this from, 1 from it, what if it was 0.9999999? It's supposed to be close enough, but it would be negative. And maybe our little check here would not work for negative. In this case, it might. But all numbers in that case would be negative. What if this was 1,000 and we did, or negative 1,000, right? And we checked to see if that number minus 1. So anyways, you want to take the absolute value of the difference. So to compare floating point numbers, take the absolute value of the difference between that number and the target and compare it to the threshold that dictates whether it's acceptable or not. So variable assignments and initialization. We've already seen that. You assign a value using the assignment operator. If you're going to compare values, you use double equals. Like that. It is not a syntax error, unfortunately, to use a single equal. If I do this, int x equals 10, and then later on I do if x equals 0. Wait, that's wrong, sorry. There. This is a syntax error, but it's wrong. I mean, it's not a syntax error, but it's wrong. Why? Because 0 is going to get copied into x. It's going to erase whatever x is. So what if we check to see if x is equal to 1? We could do cout. They are the same. Is that going to be true? Interesting class. Nobody types along with me. That's all right. I don't make you. Usually some folks do. So they are the same. No, they're not. Are these numbers really the same? No. What happened? 1 got copied into x. It erased what was in x. And then
You passed the if statement or skipped it?
it didn't skip it. But what if ultimately does is check to see if this value is either true or false, 0 or non-zero. And once 1 gets copied into this, whatever's inside the parentheses is just 1, which means true. And so no matter what you're comparing it to, it's always going to say true. Or what if this said 0, and then you did if x equals 0? It should say that they're the same, but it's not going to. Not going to say that they're the same. The reason why it did not is because this erases what's in x, and yeah, sure, it already was 0, but then it just, what's ever inside the parentheses, which is 0, and 0 means false, so it doesn't do that. It would be nice if that was a syntax error, because the chance that you meant to erase your data while you were comparing it is so slim. But it should list it as a warning. If I go up to my error list, I hope I see it as a warning. Oh, come on. You're not even showing as a warning. Wow. All right. And I've actually run into that error. I've done that when I didn't mean to. Other languages like Java, Python, just flag that as a syntax error and won't even compile. Don't do. Erases x. I'm going to change it back to where it was, though, because it demonstrated it more clearly. Right. The variable receiving the value must be on the left hand. That's just a syntax matter. I can't do 17 equals I. Or 17 equals x. They call this the LHS and this the RHS, which stands for left-hand side and right-hand side. You may see some error message about LHS and RHS. I'm not sure that that's the terminology they use in this compiler. But they say left operand must be an L value. Well, I guess they're calling it an L value because it's something that could go in the left. In other words, it has to be a variable. Now you can put whatever order you want in your comparisons, right? I could write it like that, that's legit. Or I could say like that, that's also legit. It's just when you're assigning it. Syntax, just like in Spanish, the adverbs follow, you know, the verbs, and the adjectives follow the nouns. In our language, they usually precede them, right? Guess it doesn't really matter. You could say I quickly run or I run quickly, but you certainly don't say the tractor blew. You say the blue tractor in our language. Just a matter of syntax. So variable initialization. To initialize it means you declare it and give it a value at the same time. When you're writing it like this, you don't have to declare them. Excuse me, you don't have to initialize them. You don't have to initialize any of them. Or you can initialize some of them, or you can initialize them all. Some people like to give a starting value to every single variable, whether it needs it or not. So at the top of their main, they'll declare every single variable that they're going to use, and they'll give them all the value of 0, and then later on, they'll give them other values. That's a totally legit way of doing it. It's almost overkill, but It's a totally legit way of doing it. The other way to do it is just to declare the variable right when you need it. And that's what you see when I'm writing my code. I usually don't declare my variable until right when I need it. I don't do it at the top of the method, but you can. If you took fundamentals, that's how they showed you how to do it. They had a declaration block up at the top of the module. So C++ introduces an alternate way to define variables using the auto keyword. All this keyword means is whatever's on this side, make this variable match. In other words, it works like Python, right, where you did not declare your variables. You did not have to say int amount equals 100 or float f equals 1.23. Why is that cool? I don't know. I don't know what's wrong with me deciding that that's going to be an int. But it's available to us. If you don't feel like declaring your variables with a specific type and you want the type to the compiler to figure out the type based on what's being copied into it, you can do that. However, pardon me?
You could assume that would probably lower the efficiency of the program.
Well, it depends on whether it happens at runtime or not, and I was just about to check that. What if we had this? That's totally legit. Is this okay? I don't know. I don't know if at runtime it's going to figure out that, yeah. So that would be slower in my mind, right? Because at runtime it's got to figure it out. Not that much slower, but it's got to be slower because it's got to inspect that value and then allocate, you know, the appropriate variable of whatever type. I'm amazed that it can do that.
Well, if you have like a lot of them, you could probably make it a decent bit slower, right?
Mm-hmm.
Yeah. You know what I think is really happening? I think that the compiler went, oh, you're copying X into it? Well, I'm going to go and find out what X is. X is an int. Oh, that means that Z had better be an int. And so it still would do that before runtime. And so it wouldn't actually be slower to run.
What if X was auto? And think about like maybe recursive.
It might have 20 or 30 or 40 has a check in order to do that, but it could. The compiler can work its way all the way back up to the original declaration of the value and figure it out. You'll never see me use auto in this class, and I'm not going to ask a quiz question about it. Scope. We've talked about scope before. Scope is where a variable is available and where it isn't. You can have a variable known as a global variable, which is accessible everywhere. If I come up here and I say, you know, string, you know, word equals yo, right? That's my word. I could use this word variable inside any function. If I wanted to write another function, void test parentheses like that, and I wanted to see out word, I can access that variable here, and I could access it here because it's declared outside of any function, so it's accessible to all. This is a global variable. It's global in scope. Everything else we've got in here is local in scope. I could not use fname inside test. And it's not because the order in which these are declared. It's not because test isn't above main. It's because that variable is only accessible in main. So if I did test2 and I tried to get a hold of that fname variable, it's going to call it a syntax error because fname is only available within this scope. It's only available within those braces. Not available anywhere else.
What are you using to declare those functions?
I'm using what's called void. Void just means it doesn't return a value. This is declared as int because main can return a value, and to be good coders, we really should have a return 0 at the bottom of that, and I should put it in my boilerplate. I should modify my boilerplate to have return 0 at the bottom. But since int is declared as main, the compiler should call it an error that it's not returning a 0 or a non-zero value.
So in that case, you could say string main parentheses, curly brackets, and then return a string.
Yep. I can make something called you know, poem like that, and it could return roses are red, violets are blue, and then down here I could call that function. I could do cout poem. Come on. All right. Right. So you have to, when you're defining a function, you don't use a def keyword like you do in Python. What you do is you give it a return type. And fundamentals talked about fruitful functions versus void functions. Maybe those words trigger. If it's a fruitful function, it has a return type. Like we could declare this as an integer, but it would have to return an integer for it to, you know, compile successfully. Main, for some reason, according to Microsoft, being the exception. You don't have to return a value from it even though it's declared as int. I think, I can't even explain why they did that. So
you'd have to at least declare some type, at the very least void, in order to even create a function?
right, exactly. Exactly. Because if I do this, if I don't give it a type, it thinks I'm calling a function.
Oh, okay.
Yeah.
Yeah.
It's trying to call a function named test, which I haven't declared. So I do have to give it some type. And void just means, yeah, I'm not going to return anything. If you declare a function as having a type, it has to return it. It has to return a string of whatever form.
So what's going to be the point of even having a void function? Like, just to test things with?
Not to test, but not everything needs to be returned. You can write functions, you know, what if I have a function that's going to do a whole bunch of stuff, but main doesn't care about it? Right. What if I write one function that loads my game program up and plays it, and then when the game is done, it returns to main? Well, that game doesn't need to return any data. It just played and it's done. And so in that case, I would declare it as void. But if it's performing a calculation, it's got to do it. Now, some languages make the difference between a procedure and a function. And in those languages, every function has to return a value. That's why it's a function, just like in math, right? You write a function, it's going to return a value. And then a procedure is something that doesn't return a value. And it's valid to write a procedure. There may be times when you don't need to return anything. If it's only doing output, then it doesn't need to do anything. If it's getting input, it better return that input. Does that make sense?
Okay. Yeah.
The order in which things are declared, if you've ever taken Java, they're not important. In this class and in Python, it's critical importance. If I put poem down below main, I need to get rid of that because that's a syntax error. Fname is out of scope since it's declared in main. Right. So this is fine. I declared my function here, but unfortunately I'm trying to call it up here. And what the compiler is trying to figure out as it goes down is, oh, well, what is poem supposed to be returning? Because we're going to print it out. We better know what it's returning. But it doesn't know. Java runs all the way through the file before it starts compiling it, and so Java would know, you know, if the rest of the syntax was right, that poem returns a string, and it would be able to compile it. This language doesn't. If you do that, if you declare them out of order, you can get it to work. And to do that, you declare what's known as a prototype. A prototype, oh, and by the way, like one of the quiz questions or exam questions might be, what is a prototype? Don't just Google the word prototype definition and come up with the English definition for a prototype. Right. I want the programming definition. I've had people do that. But, you know, no shame, right? But it meant that they slept through the day, or the days that we talked about what prototypes were. A prototype is a forward definition, or we could just call it a definition, of a function without a body that tells the compiler the return type and the parameters of the function, because otherwise it doesn't know. Right? The compiler doesn't know that down here, if I made poem require an int for some reason, as its parameter, it doesn't know that up here. It can't call that a syntax error that we're not doing it. So we would have to declare a prototype, and all a prototype is the function header, but followed by a semicolon. Like that. That's a prototype. Function prototype. I guess in my next exam, I'll change the question to say, what is a function prototype, so that people aren't tempted to just give me the English description of a prototype. So, that's what a prototype is. And you might ask, well, why didn't you just put them in the right order? Well, the functions might not even be in this file. You know, I've worked on projects that had, like 20 or 30 different CPP files. And that's not excessive. You can be sure that something like Word or Excel or some other really large program has probably got hundreds of CPP files in it. And something ginormous like the Windows operating system and everything, it's going to have all sorts of files. And if that function isn't in the same file as where it's being called, it won't compile unless it has access to the prototype. Now in that case, what do? You put the prototype in a header file, and then you include that header file. I'm not going to do that right now, but that's what you normally do, is stick your prototypes in a .h file so that your functions can be in a completely different .cpp file. And you do that for organizational purposes. You might put all your graphics functions in one file, you might put all your math functions in another file, and so on. So now it can call poem, right? Because it was declared above this point. All right. None of that means anything, right? But it's demonstration of the concepts. A variable cannot be used before it is defined, and the scope of the variable is a part of the program in which the variable can be accessed. So the scope of the variable is also its lifetime. If you create a variable halfway through the function, it can't be accessed before it was created, but it can be used everywhere after, or at least within the curly braces in which it was defined. If I put a variable inside an if block, it disappears when the closing brace of the if block is found, right? So if I create a variable here, and you asked a question about variables, how you could redeclare a variable, so I know that we've talked about this talked about this last time. I can't access this here, right? I can't see out wow, because it's out of scope. So it really won't compile. Value is not defined yet? Sure enough. Can't print it out before it's defined. One thing that beginning programmers tend to do, and I would expect y'all not to be doing this. If you do, it's okay, but it won't work and you'll just have to fix it, is, if I give you an assignment that says, the ideal gas law is P equals V over this and that and the other, right? So if I say the gas law, or this equation, this formula is used in your program, so my homework could say, the ideal gas law is, right? Write a program that lets the user enter values for N and T and V and calculate P. And people go, okay, that's definitely pretty important, and I'm not making fun of them. It's just something that you have to learn painfully if, okay, what's the problem with that? P, N, R, T, and V, none of those are defined. And so usually what happens is you put that up at the top, for the students who make this mistake, and then they declare their variables, and then they get all their input, and they expect it to work. I have the formula in it, but it's in the wrong order, right? You got to buy the eggs before you can make the omelet. Haven't seen that yet. Haven't seen that in this class. Usually that's in 1113 that I see that. Arithmetic operators. Three kinds of operators, broadly speaking, that do math. This is the most common kind, like addition, subtraction, multiplication. And in order to do any of those things, you have to have two, right? You have to have two pieces of data to add two numbers or multiply two numbers or whatever. So those are called binary, meaning two operands. Not binary as in it's ones and zeros, although of course ultimately it is. Binary meaning two. Well, what would trinary mean or ternary mean? It means there's three operators in it. Well, that's a weird kind of thing. How could you have something with three operators? Well, we'll show what that means. And then there's unary, which means one operand. And there's really not very many unary operators. But the minus, the hyphen, does double duty as an unary operator and a binary operator. If it's a unary operator, it just flips the number that comes after it to be negative, right? We think of -5 as being a number, but the computer thinks of this as being 5 that was flipped to negative by that symbol. So what is this doing? What this does is it evaluates that expression. And if this expression is true, then that is what's returned. Else, that is what's returned. So like in our code. Int temperature is 12 degrees outside. And then I'm going to write a statement. String S, or string result, or whatever, is equal to, and I put parentheses around this part, but it's not part of the syntax. It doesn't break it, but it's not necessary. If the temperature is less than 32, question mark, is it less than 32? If so, then our result is freezing. Else, there has to be a symbol to mean else, it's not freezing. Semicolon. It's called a ternary operator, ternary, trinary, 3, because there's 3 components of it. There's that component, there's that component, there's that component. It's not really an arithmetic operator, is it? I'm not sure why it's in the arithmetic operator list. Although these could just be numbers, right? We could say int result, and if it's less than 32, then result gets stored as 100. Else result gets stored as 200, right? And then it kind of looks like it's doing math, but it's not really. It's just an if statement. It's doing the exact same thing as if we had done this. If temperature less than 32, then result equals freezing. Else result not equals not freezing. Right, like that. These two things do the exact same thing, except that one's being declared, right? So if I declared that on its own line and then did result equals, same business. They do the exact same thing, both of these. And this does it in one line rather than 4. You even need it? Not really. Does it make the code easier to read? Not really. But if you can think of a time when it's useful to use, go for it. That's the ternary operand.
That's still technically initializing?
In this case, it's not being initialized. Good question. It's a subtle difference, but initialization is called initialization only when it is given a value as it is being declared. To me, this is initializing it with the result of that, right? Because it's the first time it got a piece of value. But technically, the book definition is that it's not initializing, it's merely assigning. So if we do this, int t2, this is, and then we turn around and say t2 is equal to 3, this is a declaration. This is an assignment. And this is a declaration plus an assignment, which is known as an initialization. Now, am I always that precise? You know, if I come down here and I say, okay, I'm going to initialize result to freezing if it's less than 32, you understand what I mean. But I really should say assign if I want to be precise. That makes sense?
Mm-hmm. Well,
Yeah.
I think a moment ago, before you actually called result, you had the temp less than 32 line included with that.
Oh, yeah, yeah. When it was like this, absolutely. It is calculating this result. Everything on this side of the equal sign happens first.
No.
It's like this doesn't even exist. All of this happens first, and then if there happens to be equal sign, it takes that value and does whatever it needs to on this side, which in this case is initialize that variable.
So that is initialization?
That is an
Oh, okay.
initialization. Yep. Yep. Wasn't until we moved it up there.
Gotcha.
Even though it was just separated by one character turn. Well, that's not true. It was separated by a semicolon and a character turn. Made it two statements, so it wasn't initialized. But if I had written this, I would be very prone to calling it an initialization, even though it's not strictly. Binary arithmetic operators. Addition, subtraction, multiplication, division, and then modulus. Modulus just means remainder. 3 goes into 7 one time with a remainder of 1. 3 goes into 8. Did I say one time? 3 goes into 7 two times with a remainder of 1. That's why 7/3 is 2. Well, why isn't it 2.24 or whatever 7 divided by 3 is supposed to be? Because that's an integer and that's an integer. And in most programming languages, but not Python, if you take an integer and divide it by another integer, the result is an integer. And the fact that the result is an integer means that it flat out can't have a decimal point. So it rounds it down and truncates it. So 7 divided by 3 really is equal to 2. And 1 divided by 2 is equal to 0. Sounds weird. 1 divided by 2 isn't 0. Well, it is if it has to return an int out of it. And it does because these are ints. If we changed one of them, right? If I did this and made it 7.0 divided by 3, then it really is going to equal 2.2 whatever, or whatever. 2.7, I don't know what it's going to equal. But, yeah, 2.3 is closer. So it's like if you do this division and then took the remainder, that's what that means. 7 divided by 3, remainder. 3 goes into 7 two times to the 1. If we made this an 8, 8 divided by 3 is still 2. So 8 modulus 3. And that doesn't mean, by the way, that you have to do this statement before you do this one. This is an entire, a statement unto itself. 8 modulus 3, 3 goes in 8 two times with a remainder of 2. 9 modulus 3. Well, that's evenly divisible, right? 3 is a factor of 9. 3 goes into 9 3 times with a remainder of 0, because there's no remainder. So please, 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 please remember that an int divided by an int results in an int, rounding down. And sometimes you wouldn't think that was important. Well, what if we did this? Int x equals 4. And then we did cout 1 divided by 2 times 4. And then when it prints 0, we get very annoyed. Shouldn't be 0, right? We'd like for it to be 2. But it's not, because it does it left to right, since the operators are all of equal precedence. And 1 divided by 2 is what? It's not 0.5, because these are both integers, so it rounds it down to 0. And then 0 times 4 is that. So, if this was a double, it might have a chance of working. But the real way to get it to work would be to turn one of these or both of these into fractional points. And honestly, if I was going to do that, you'd do that, right?
Yeah.
And then it would work. But there are times when you get equations like this, The formula for the volume of a sphere is 4/3 pi r cubed. And so you'd be tempted to do this, 4 divided by 3 times that, times that, times that. Well, 4 divided by 3 is just 1. The equation's not going to work too well, so you'd want to make it 4.0 divided by 3. And why not put the value of 4 divided by 3? Well, because that's 1.36, and it looks silly to type that. The other thing you can do is carefully arrange it, right? 4 times pi times r, times r times r. Divided by 3, you put that at the end. Then it has a much better chance of working. But if you make them floating point, then you don't have to worry about it. So an int divided by an int always results in an int. And so I'm going to put here, this prints 0. Why? That means modulus. 4 modulus 2 is 0. 5 modulus 2 is 1. A way to check to see if something is odd or even is just to modulus it by 2. If x modulus 2 equals 1, then that means it's odd. If x modulus 2 equals 0, that means it's even. This is what I've been lecturing on for 5 minutes. It does integer division if both operands are integers. 13 divided by 5 is actually 2. 91 divided by 7 is 13. Even if there's some fractional point, it disappears. But if you make one of them or both of them floating point, then you get your floating point answers. So modulus computes the remainder. In this language, unlike a few, modulus requires integers, which kind of makes sense to me. If I have 13.2 modulus 7.1, that kind of breaks my mind. I know it works. Okay, comments. We know what comments are. They document parts of the program. There's 2 kinds of comments. There's this kind, and then there's this kind. When I'm jumping into a huge burst of notes like that, I should just start one of these. If there's some chunk of code that you need to get rid of temporarily for testing purposes, you could always do this at the beginning of it and then do that at the end of it. Now, I've broken the code, I'm sure, because something relied upon X and whatever. Right, that's called commenting out the code. There's even a keyboard shortcut for doing that. I wouldn't comment out the code like that necessarily if I had the option of using this menu, which I do. Go to Edit, Advanced, it's here, Comment Selection, and it just puts / in front of everything. And when you're ready to uncomment it out, you need it back in your project, Edit, Advanced, Uncomment. Notice there's also things for increasing indent and decreasing indent. I don't know why they don't show that there's a keyboard shortcut for it, because what's the keyboard shortcut? It's just to highlight everything and hit the tab key. Or Control Tab. Nope, Control Tab didn't bring it back like I thought it was going to do. In some languages it does. How about Alt Tab? Nope.
Shift tab, maybe?
Pardon me?
Maybe Shift tab?
Yeah, Shift Tab. You got it. Thank you. There you go. Shift Tab brings it back. By the time your code starts getting confusing because it has different levels of indentation and you've deleted braces and something is not working, this is a very common problem. If I forget that, then I compile it. I'm not going to compile. Build errors. And it can be hard as heck to figure out what's wrong. Local function definitions are illegal.
Going to jail.
You go, what? If you ever see this one, this is the best clue. End of file found. If you ever see end of file found, you know that you have braces missing. you've got more open braces than closed braces, and then it just becomes a matter of really closely eyeballing it. And if you've done a good job of tabbing, then it'll be easy to spot. But you may not have always done a good job of tabbing. If you need to clean up your code to try to get it tabbed correctly, sometimes this works, sometimes it doesn't. I don't know the pattern behind that, but if you choose format selection or format document, it's supposed to try to tab it correctly. Let's see if it does today. I don't remember where my mistakes were, but I think it did. I think it fixed it. Yeah. They are ignored by the compiler. Single line comments, we know what they are. Multi-line comments, we know what they are. Named constants. A named constant, you just use the const keyword, and it's just an agreement by programmers that if you have a constant, you name it in uppercase letters. It's not going to break the code if you don't. It's just a convention. And that means that this value cannot be changed later. If some goofy person decided that in the middle of main it was a good idea to change the tax rate to something else, it would not compile. They'd have to go up and change it in the one place where it was defined. Programming style. The visual organization of the source code, including the use of spaces, tabs, and blank lines. So, you know, I try to make the code real easy for y'all to read, and I try to put lots of spaces. I wind up putting spaces that aren't necessary. That's valid code. That's valid code. This is valid. That would be invalid. Got to have that space, right? But anyways, yeah, you know, this is all good code. Well, except for that, right? And when I say good, it compiles. There's nothing wrong with it, but it's hard to read. So you try to make your code readable. Readable includes using white space, like that's a bit excessive, right? But that makes it easy to read. That makes it easy to read. Breaking up sections of code with blank lines, just like you separate paragraphs with blank lines, you know, sometimes when you're typing something up, makes it easier to read. Now, sometimes I cram too much stuff together by, you know, because I'm trying to get the most of the stuff that I possibly can on the screen. But usually I don't. Usually I try to space it out just like I would if I was writing professional code, with lots of white space to make it easy to read. One thing that people do, which can result of people getting into fisticuffs because they're angry at each other. No, I'm kidding. But brace placement is a matter of religion to some people. They want to do it like this because when the language was invented, the inventor did it like that, right? And if you feel like doing it like that, that's fine. If you feel like doing it like that, that's what I recommend. That's what all of our code examples in the book have. This is called block placement. This is called K&R style. K&R being Kernighan and Ritchie, the people who invented the C language in 1970, because they liked it like that. Feel free to use whichever one you want. It's a matter of style, just like that slide said. Okay, let's do a little bit of a program so that we can justify having some homework on the concept. I'm going to go up to the top of main. And in fact, I'm going to put a system pause here just to stop the rest of the code from running. Of course, if you're doing this on a Mac, you don't have that option. Tell you what we could do. C out, hit enter, \n, and then we could do CIN into some dummy variable. I don't even have any variable defined, but I could, right? I could declare a string named S so that I could do that bit. All right, I just did that so that I can put my program up here at the top. So what is this going to do? Calculate the density of a substance based on its mass and volume. So I'm going to need three variables, D, M, and V. And let's say that I really liked declaring them before I use them. So I might do double D, double V, and double M. And I could declare that this is volume in cubic centimeters. And it doesn't really matter if you understand the math or not. You can always write a program if it's well spec'd, even if you don't understand what the calculations are. It helps though, right? And then this is mass in grams, and this is density in grams per cubic centimeter. All right, why don't we ask the user for each one of these things? Well, two of them. We're going to be calculating D. I feel like cutting this out and putting this down here. I don't know why, but since the equation is D is equal to M over V, I kind of want D at the bottom of that. It didn't matter. But let's ask for what the volume is. Cout, what is the volume of material in cubic centimeters, question mark, space, space, greater than, end quote, semicolon. Now I need to let them type it in. So CIN greater than V. Man, it's cold in here. Or is that my imagination? Do they run the air conditioner even when it's 32 degrees out there? I mean, it seems that way. Alrighty, and so Cout less than, what is the mass in grams? Question mark, space, space, greater than. And you know why I like that greater than. It's just to show them where to type. It's not necessary. End quote, semicolon. CIN greater than M. And then I need to perform my calculation. I could add a comment as to what this section is doing. Gather input. Gather input. This next line down here, this next section down here would be calculate density. And that's just D is equal to M divided by V. And then I'm going to print the results. And I've added so much white space now that I can't really go further without scrolling these things off, so I hope you have that part. Y'all okay with me scrolling?
Yep.
Alrighty. So the last thing is output results. Cout less than density of material is, end quote, less than D, less than quote, grams per centimeter cube, backslash n, end quote, semicolon. And I hope it works. Let's find out. No. Double D redefinition. Yep, that's true. All right, what's the volume of the material? Well, if it's 10 cubic centimeters and its weight is 10 grams, then 10 divided by 10 is 1. And I'd kind of like for there to be a space between that 1 and the G, so I'm going to modify my output statement just a little. Going to come back up here and put that there. All right. So why did we show all this? Because I'm going to have y'all write a program that uses the ideal gas law, and you're going to input these things to calculate the pressure. Now I wrote this up for my Java students, and I'm going to give it to y'all as an assignment as well. So as soon as we know that nobody has any syntax errors who's trying to get this running. Alright, so here's your homework, except I'm going to modify it slightly. Of course, I will modify it when I post it right. Homework. Write a program that declares these variables, P, V, N, R, and T. Make them all double. Declare them one per line, and then add comments to each line saying what the variable represents. P is the gas pressure in atmospheres, right? Like right now, where we are, the pressure is about 1 atmosphere, and if you went on Everest, it'd be a lot less, right? 0.5 atmospheres or something. The V is volume in liters, the N is quantity in moles, and already you're thinking, this isn't a chemistry class, why are you making me do this? Well, you can do the assignment without understanding the math, right? R is the ideal gas law, ideal gas constant, and T is the temperature in Kelvin, where the absolute coldest temperature is absolute 0. Whereas if you measure it in Celsius, the absolute lowest temperature is negative 273.15, which is a weird number, right? So they made another scale where 0 is the absolute coldest. So part 2, assign values to V, R, N, and T. I'm just going to change this to ask for input for everything except for the constant. That's the constant. So you're not going to ask the user for that. But you will ask them for the volume, for the number of moles. Don't worry about what moles are. And what the temperature. And then calculate the pressure using this formula. PV is equal to nRT. Oh, and I forgot to put a step 4, which is display the results. Hope my Java students get that. I guess I could edit it right now. That makes sense, gang? I'll post the instructions in the homework box. Are we good? We know how to do that based on our homework? Yeah. Sorry, I got Pat off it. Let's end for today, even though it's a few minutes early. Let me make the Dropbox, and then I'll bring the source code back. Oh, I made the Dropbox already. Wow, I thought I had. Alrighty. So, are there any questions? Everybody can do that based on what we did? Nobody's saying yes. Nobody's saying no.
Yes.
Yes. Alrighty. Good. We're confident.